CSS gets more and more powerful every year. I still fondly remember the days where if you wanted things to animate on your page, you'd have to use a marquee for it. And now things have changed. CSS can do so much. From light mode and dark mode, to scroll smoothing, to scroll snapping, to sticky behaviors, to even doing 3D transformations. CSS has gotten really powerful. But how powerful is it? Can you make real things with just CSS? Can you replace your SQL database with CSS? Can you replace your JavaScript with CSS? Can you replace your game engine with CSS? Well, I have an interesting thing to show you guys today. I'm not sure about the SQL thing, but it does look like your game engine can be just CSS now, because this is CSS Minecraft. There is no JavaScript on this page. This page where you can build blocks, break blocks, rotate, and do so much more, all just using CSS. This is absolutely wild, makes no sense to my feeble CSS brain that just lives in Tailwind. I have a lot to dig into here, and I hope you're excited to go on this journey with me to figure out how the hell you can use CSS to do something this absurd, because this is genuine insanity. Someone's going to have to pay my therapy bills for this, so quick word from today's sponsor, and then we'll dive right in. There's never been a better time to be a developer. That said, I feel like we have to make way more decisions than we used to have to make. What framework do we use? What database do we use? Where do we host that database? Where do we host our code? Do we go servers or serverless? And what provider do you have to pick in order to get all of these things right? If you're like me and you're starting to get tired of hopping between all these different services, today's sponsor's here to help you out. Savala's figured this out because they already figured it out at Kinsta, the WordPress host, because in order to host WordPress, you have to do all of these different things. Now with Savala, they're giving you the magic that they built for themselves to use for anything. And when I say anything, I mean it. They have a new template platform where you can one-click deploy a starting project for basically every tool or framework you'd want to use. From Next.js to Pocketbase to Mongo to Moodle. I have memories with Moodle. We used that when I was in high school. That's crazy to see it here. They have a ton of options throughout this, though. Another really cool one that's in the corner here, my face is covering a bit, Firecrawl. They're actually another sponsor of the channel, and they're fully open source. So now, instead of using Firecrawl's infra, which honestly, in this case, you should, they're really cheap. But if you really need to keep things internal and self-host it, one-click deploy. Pick the region you want it in. Now it's deploying. And as you see with something like Firecrawl, it's not just one project that it has to deploy, because there needs to be a database, an API, and also a server that runs Playwright to do the headless browser. And these templates will spin up all of these things for you on demand. And reminder, they're spinning up real services for you on real servers. They're not spinning up some Lambdas and billing you a bunch of money for it. They're just giving you a server with a way better interface for managing it. They'll even handle the annoying multi-cloud stuff, like putting Cloudflare in front of your deployment so that you can have DDoS protection or enable or disable a CDN with literally one click so that your static assets can be on the edge instead of being from your server. If you're not using Savala, you've either spent a bunch of time doing all these things yourself, so you see how useful it is, or you haven't done these things yet, and your service is way slower and less reliable than it should be. If you don't believe me, try it yourself. You'll get $50 of credit for free at soydev.link/Savala. First and foremost, shout out to Benjamin Astor here for creating all of this. His site has all sorts of really cool, crazy projects. I highly recommend checking it out if you're a nerd about browser stuff like we are here. But we're here to talk about one specific project, CSS Minecraft, which he was kind enough to open source. And as you see here with languages, he's not bullshitting. Obviously, I had to clone the repo because I need to play with this. It's just far too cool to not. Doesn't specify how it did things, but this index.pug file, I'm assuming this is used to generate the content because it's got to do a bunch of loops in order to add all of the blocks and things in the HTML. The output HTML file is a big one. It's like 4 megabytes. It has 45,000 lines of HTML, 46,000 lines of HTML. Of course, Simon has a blog post on it. My favorite AI blogger, also the creator of Django, did his breakdown of CSS Minecraft. It's just 480 lines of CSS and 46,000 lines of HTML. The key trick to get this to work is labels, combined with the has selector. Since the page has 35,000 label elements and 5,840 input type as radio elements, those radio elements are the state storage engine. That's actually really clever because inputs have a state, and that state is accessible in CSS because you use it to apply different styles. So when you click something, you are toggling a radio on and off, and that radio toggle has a value that can be used to determine what happens. When the stone radio button is checked, all cube elements except those with the .stone class are hidden. Display none. Here's a shortened version of the template. Because again, they templatified it so that they could encode this more easily. Air, stone, grass, dirt, logwood, leaves, yada yada. Underscore layer in array. Layers, rows, column. So every one of the 9x9x9, 729 cubes, there's a set of 8 radio boxes sharing the same name, cube, layer, 0, row 0, column 3, which means it can have one of 8 values. Air is clear space, the others are material types. 6 labels, 1 for each side of the cube, and those labeled 4 equals attributes target the next block over of the current selected visible material type. The way the rotation works was actually one of the things I was most curious about. Because I know you can do some cool transformation stuff in the browser, but without JavaScript, how do you know when to start and stop it? Again, Simon figured this out and broke it down for us. The way it works is when the control has up active or down active, it sets the animation state to be running. And the animations that are defined are relatively simple. From Y0 to calc -1 var max rotation for the max rotation. Now it has these animations defined. So when you click, it will run that animation. When you let go, it stops running. So it just keeps running until you let go. So like I'm clicking now, let go, now, let go, now. You get the idea. It's so crazy that it has like proper 3D. The thing you can't do is like click and drag around because it's CSS, but making everything work and animate properly in 3 dimensions is just fucking insane. This is so cool. Tom Wildenhain is the most underrated engineering channel on YouTube. I forced far too many people to watch in its completion the Turing completeness of PowerPoint. Link will be in the description. I highly recommend watching this if you haven't yet. But I just want to show one particular beautiful part. The whole thing is worth the watch, though. The pacing's incredible. Tom managed to make PowerPoint Turing complete. The way he does that is incredible.
So here we have a Turing machine that decides the language palindromes of even length. So you can see that, like a normal Turing machine, we can move this tape. This is implemented completely with animations. There are no macros or anything else. So I can write to the tape, of course, so we'll give it a simple input like this. And of course, I can also execute the Turing machine. So here we have the Turing machine's current state. And in order to continue execution, unfortunately this doesn't happen automatically, it needs a little bit of encouragement. The user has to click on each orange region. Now you might be concerned here that I'm making decisions whenever I'm clicking on this, but the way that this PowerPoint is set up, every other area is blocked. So I can click randomly essentially, and the PowerPoint will just advance its computation. So that was the input 1.1, so this should end up being accepted. And we can see that it does indeed end on an accepting state.
Art.
And I can rerun that with another input, and it would reject accordingly depending on what it is. So this is nice, but what we'd really like to be able to do is run any Turing machine in PowerPoint. Fortunately, this is easy because the PowerPoint Turing machine is programmed entirely using punch cards. So for example, this card says that whenever the Turing machine is in state 0 and it reads a 1, then it should write a blank, move to the right, and then move to state 2. But if we change where these holes are located, we can make the Turing machine do something else and essentially imitate any transition function of any other Turing machine. All of this is accomplished using over 1,600 animations and around 700 auto-shapes.
I hope this emphasizes why I thought this was relevant. If you can encode enough data into an application, you can make it be a different application. When you have the ability to make enough different states somehow, you can make anything else happen. And the way that this CSS Minecraft thing does it is creating all of these labels. And since labels for inputs have properties that allow you to apply different styles, you're able to do really cool things with them. I do want to dive into the code, though. Let's do this. He did write the SCSS. I'm assuming that this is what becomes the compiled CSS, because this is only 485 lines, and the actual CSS is actually about the same. Interesting. But I'm sure the SCSS is a little more readable. I don't think he would have included it otherwise. That's at least my assumption. So we create the variables like pickaxe, image, stone, yada, yada, to get all the images that we need. Body, cool. Nothing interesting there. info section up top. Then controls. This is the control section. Block chooser, label, display block. For each block in blocks, background image is set to the variable here so that we get the right image. I'm actually curious how that maps to traditional CSS. No, it doesn't. So instead of that being just variables, the official CSS creates the different classes for it all. So one of the things that's cool about CSS, you can effectively write loops and it will compile that into the real CSS. But this is way more readable. You got @/air, background image, var pickaxe, hover, outline 2 pixels solid silver, has input type radio checked, outline 2 pixel solid white. Very cool. This is, if it has a checked input, then we outline it. This is all still just for choosing which type of block. So that is here, when you click one, which one are you currently selecting? Nice and simple. Block and blocks has, cool. We get all that. Move buttons, same deal, just styles to make them look right. Here is where that animation code we were talking about before happens. If it has look down, we run it, otherwise we don't. And here, things get fun. So again, CSS supports 3D. You can add perspective and an origin for that perspective and then transform while preserving 3D. 3D CSS is still so cool. I'm waiting to see more cool uses of it. It seems so incredibly powerful. RIP 3JS, right? Sure, AGI can debug bugs and make to-do apps, but until it intentionally spends time to run Doom and TypeScript types or make Minecraft with CSS, it's not true AGI. Yeah, I agree. If it can't waste time on things like this, it's not going to replace devs anytime soon. Animation duration is 10,000 seconds so that you can just turn it on and off and never worry about it going too long. That's great. Max translation, 400,000 rem. Rotation is 3,000 turns. This is great. This is like your classic Z-index infinite. Initial camera position, translation, that all makes sense. Look up, look down, transform origin, cool. These are the different animations being defined. So look up, animation, var, animation duration, linear, yada, yada, key from, to. We already read about how all that works. Let's look at how the block placement works, though. Blocks. Position relative, translate, calc, var columns, var cube size. So this is how it gets its position depending on which column and other variables exist on it. Yeah, we can see here label 4 equals, if my face doesn't cover it, label 4 equals cube layer 7, row 7, column 6, stone, class, front. There are a bunch of other ones here because these are all the sides if this cube is stone. The cube could also be air or grass or dirt or log or wood or leaves or grass, and all of them can be. So for each of these cubes, it could be any of these things. So if this is the toggle that's turned on because it has this input type radio, can I uncheck it from in here still? What I could do instead is if we select a different stone here, I'll mine that so it's gone, but we're still here. I'll change cube grass and I'll turn off the display none, and that should have rendered that. Oh, is this display none right now? Yes, this is display none. This is complex enough that my quick digging and turning things on and off does not appear to be enough to outsmart it. Very interesting. CSS checks the radio state. Yeah, it does, but I thought I would be able to brute force rendering it by turning off display none. It probably applies additional things on check true, which makes sense. I just hoped I could play with it more. That's fine. For each block and blocks, if it has cube number block and input type radio is checked, background image is set to that. Okay, there we go. So the background image isn't being set unless this is checked. What happens? Oh, I'm not running it locally. I was gonna say, what happens if I delete this, but it's non-trivial to get this running and automatically updating. This is so cool though. Cube, position absolute, block size, inline style, that all makes sense. Input type radio, absolute, opacity 0, pointer events. This is a fun learn. Image rendering pixelated is super useful. Most browsers and image renderers will not try to preserve the actual pixels in an image, and it causes them to look really weird. So this is when I learned about that flag. If I go in here and I change the CSS for that, so you can see this is pixel art, image rendering pixelated. Do you see the difference there? The browser likes to interpolate the image to make it look smoother because for things that aren't pixel art, it looks better. But for things that are pixel art like this, it looks way worse. Most of the time I see pixel art in the browser, people didn't turn this on, so it looks awful. What I didn't know is that this is handled properly even in 3D, which is a really cool thing to learn about. Always fun to see what things you can learn as you explore these types of projects. Applying different brightnesses to front, back, left, and right. Interesting, but it made it look really good. Like, I could not spot any weirdness in how this is rendered. It does admittedly take a second to load. Once it does, like, everything looks pretty good. This is particularly funny when you remember the history of Minecraft, because Minecraft started as an in-browser Java applet. Imagine if they just built it with CSS instead, how much more extensible it could have been. Performance is like 10x better than actual Minecraft, actually, though. That's really fun. If you turn off the preserve 3D, you just get it on like a flat view. Oh, and if you turn off perspective, you get like a flat 2.5D grid. That's so cool. This looks like you're playing fucking like Roller Coaster Tycoon or some shit. That's so cool, actually. Holy shit. CSS is nuts. Do you see how cool that is? That you can switch from like warping the perspective based on the distance to just not doing that. This is a lesson on how camera lenses works too. All of the like up, down, left, right stuff is applied as layers. So content look up, down, forwards, backwards. These are all wrapper divs because they have to track the animation. And the only way to have state for it is to have it be a child. Because like it can't reference a variable. It has to reference a parent. So now it can reference all of the data by referencing all of the parents. It's kind of crazy. Okay, I wanted to dick around with this in like my own sandbox, but I was struggling to hack it through browser stuff. So I just grabbed this random code pen instead to play with. And now we have a beautiful CSS transform here in Node.js. So I can minimize the JS editor and focus here on the CSS. So here we see the transform, perspective 75, rotate 18 degrees. If I change this to like 50, it gets more rotated, has a border color, background color, pink. There we go. Pretty fucking cool. I'm still so blown away with 3D CSS. Especially once you start adding animations, it can get really powerful. Like this magic pattern example. Yeah, I love this tool, by the way. We use this for a lot of the gradients and things for T3 chat. Magic pattern is super useful. Here, it has a little animation. And again, Node.js, because you can do so much animation work in CSS now, you might as well. This is actually super simple. Transform perspective, rotate, border radius, shadow, and the transition. Transform, 1 second, E0. And you have on hover, perspective changes from 1500 to 3000, and it rotates to 5 degrees instead of 15. Let's change it to 0, and we'll have the default be 50 to exaggerate it a bit. How cool is that with pure CSS? I hover it, and it flattens, and then I move away, and it unflattens. And the shadows and all the other elements are handled properly. Change this to 500 milliseconds. And that's like a snappy little thing. I think this shit's so cool. I'm such a nerd about these things. But it also makes me sympathize with the people who have to try and squeeze this stuff into the browser. Like, imagine writing the code for this to work. I would not ever want to have to do this. Oh, that's so cool. When it's all zeroed out, it just looks like a standard 2D thing. But then you rotate and you realize, oh, it is not. This is all just changing the CSS right now. You can translate to make it closer or further away. You have all the different dimensions. You can skew to make the image warped. Perspective is like, how much do you want to have like the camera warp effect things? The origin can change too. Oh, this stuff is so cool. We have literal 3D CSS, not like, oh, you can kind of, no, we have literal 3D CSS. We can layer everything in the browser in so many cool ways, yet we're still fighting z-indexing every day. Like, how did we get here? This stuff's so cool. Anybody who says browsers and like web dev stuff's easy hasn't done anything fun, because this shit's so cool. I know it's silly to say, but I do legitimately hope we see more like tastefully implemented 3D stuff in the browser, because when done right for layering and perspective, just having a slight bit of animation on things when you hover over them is just really cool. I'm blown away with all this. I think it's the coolest shit ever. I'm curious how y'all feel. This has been great. Thankful for everybody for helping me with sources and all these cool pieces in order to show off how dope this stuff can be. 3D scroll-driven animations is so cool. It's so cool you can do all of this without even needing JavaScript now. The laptop's being to CSS2. Of course it is, Jay Hay. That's just how you are as a person. This is awesome. I am pumped. I hope this inspires you to do some crazy things with CSS. And until next time, peace, nerds.